Welcome to my video lecture. In this lecture, we are going to discuss about non-competitive inhibitor reaction. So, this non-competitive inhibitor reaction also is called a mixed inhibition reaction. The reason is the inhibitor, the non-competitive inhibitor is able to bind both in free enzyme and as well as in the enzyme substrate complex. Whereas in the previous lectures we discussed about competitive and uncompetitive reaction. In both, either it will competitive only binds to the free enzyme, whereas uncompetitive only binds to the enzyme substrate complex. Whereas this is a combination of both. That is why we call that is a mixed inhibitor reaction. So, let me write the stoichiometric equation for a single substrate reaction. So, this is a common like an equation. So, your non-competitive inhibitor binds like this. Also, it binds to the so both these EA and ESI is become inactive compound, right. So, we assume that the combination of this particular rate constant we can say Ki1, whereas this combination is Ki2. I refer the other inhibition reaction how this Ki forms. So, based on our earlier experience on equation as well as the other inhibited kinetics, we try to find the equation for this non-competitive reaction. So, the first point is we need to calculate the rate of reaction, that is dP by dt. So, I have made a mistake here, is not E, is E plus P. So, the product has to be formed, right. So, this is V dP by dt. So, from this only P is there. So, if I want to calculate, this is K3 into ES. So, take equation number I, but the EI is not measurable in terms of experiment. So, we need to replace that with the known quantity. So, from our earlier experience in developing equation for other inhibitor, we can say at steady state all our intermediate, so that is DES by dt, DI by dt and DESI by dt, all is become 0. So, if I am simplifying this equation to calculate this, if I try to calculate DES by dt, from this we can arrive on an equation like Km is equal to ES by ES. This is comes from the enzymatic reaction of this. So, you can say this is equation number 1. Similarly, if I am calculating dI by dt, from this equation we arrive Ki1 is equal to EI. This is equation number 2. So, if I am calculating DESI by dt, from this equation you will get Ki2 is equal to ESI by ESI. This is equation number 3, right. So in order to understand how it comes, you can refer other lectures in this same channel. Enzyme, the total enzyme E naught, so is present in any one of these form, like a free enzyme E, or enzyme substrate complex ES, or enzyme inhibitor complex EI, or enzyme substrate inhibitor complex. So you can say this is equation number 4. Now what we are going to do is we are going to substitute that ES, EI and ESI into another form with the help of these equations 2, 3. Let me start with the equation number 3. So equation number 3 is this. From this, if you want to calculate ESI, ESI is nothing but Ki2 into. So similarly, in equation number 2, we can find out what is the EI. So both 3 and 2, I am going to substitute here. So it's become E. So ES. Now instead of EI, I am going to substitute EI Ki1. Similarly, if I am substituting ESI with the help of equation number 3, this become ES I by Ki2. Now in order to get simplify this, we assume that Ki1 is equal to Ki2. So instead of both, we are substituting capital Ki. So there is a small variation definitely will be there between Ki1 and Ki2, but in order to come to a bigger picture, in order to simplify this equation, we are negligible that difference. So that's why we are assuming that as a Ki. So in that scenario, this Ki1, so this equation is become equation become Ki, right. Now we have some common terms in this equation. Let me point out that. So this is a E is present here and also present here. Similarly, the ES is present here, also present here. So you can take those things commonly so that you can combine the equation. So if I am taking E out, so from this equation, it's become 1 plus from this equation, if I am taking E out, is become I by Ki. Similarly, if I am taking ES from this equation become 1. Again similarly from this, if I am taking ES common, so it is become I by Ki. Now you can see both these terms having 1 plus I by Ki. So that can be taken out. 1 plus I by Ki, if I am taking out, so the remaining term is E plus ES, right. So let me erase the other side so that we can continue. Now substitute equation number 2 in this, sorry 1 in this. So what is 1? Km is equal to ES by ES. So from this you can find out ES is equal to, sorry, find E from this is equal to, E is equal to Km into Es divided by S. So you substitute this equation in this. So your E naught become 1 plus I by Ki Km Es by S plus Es. So simplifying this, how I am simplifying, again I am taking Es common, so that I am taking out Km divided by S plus 1, right. I am erasing the left hand side so that we can continue. So just to continue with the simplification. So E naught is equal to 1 plus I by Ki into Km divided by S plus 1 into Es. So Es become E naught divided by 1 plus I by Ki into Km by S plus 1. So you take the LCM here, so you will get E naught. So I take this part up so that if I am taking LCM, this is Km plus S, whereas the bottom S, that is divided by S. So this S can go up. So it is become Es E naught divided by 1 plus I by Ki into S whole divided by Km plus S. So you can take this equation number 5. You now substitute 5 in equation number 1. Let me erase this. So what is our first equation? I equation is I is V is equal to K3 into Es. So substitute 5 in I. So it's become V is equal to K3 into E naught divided by 1 plus I by Ki into S whole divided by Km plus S. So we know that K3 into E naught we substitute as Vm. So this equation, so let me erase this side. This equation become V is equal to Vm divided by 1 plus I by Ki into S divided by Km plus S. So this will be rewritten like Vm star into S divided by Km plus S. So again the symbol is used by different books in different way. Here the where Vm star is nothing but is equal to Vm divided by 1 plus I by Ki, right. Let me erase this. So, according to this, we can, if you compare the Vm and Km for a normal reaction and inhibitor reaction, so we can find in this case the Vm for a inhibitor reaction. So, Vm is nothing, Vm star is the inhibitor reaction. So, the Vm star is actually decreased when compared to the Vm by the fold of 1 plus I by Ki, whereas Km of inhibitor reaction is unchanged with the normal reaction. So, if I am trying to replicate this in LB plot, let me see how it is. Let me erase this. If I am drawing an LB plot, so 1 by V versus 1 by S. So, this is your, say this is a normal reaction, say I is equal to 0, that is there is no inhibitor, normal enzymatic reaction. If I am draw for a non-competitive inhibitor, this reaction is become like this. So, this is a non-competitive inhibitor, because this is a 1 by Vm for this, this is a 1 by Vm for this. So, there is a decrease in Vm whenever there is a non-competitive inhibitor, whereas this point is minus 1 by Km, where this point is not changing. So, this is how we need to find out whether the inhibitor is a non-competitive inhibitor, right. So, this how we need to develop the MM equation for a non-competitive inhibitor. Thank you.